Hi, in this video I'm going to be looking at the logarithmic laws that deal with change of bases. I will make use of one or two of the logarithm law regarding mainly the power law, which I have in an earlier video. If you haven't seen that, or if you don't know that the power law, you might take a moment to have a look at that video. But anyway, in this video we are going to prove two identities, and one is that log base b of a is equal to 1 over log base a of b, i.e. if we interchange the logarithm and its base, one is inverse of the other. And the second one is that we will show that log base b of a is equal to log base c of a divided by log base c of b. This particular relationship is quite useful because most calculators give you logs in either base 10 or the natural logs, which in base e. So if I want to work out, for example, log of 5 in base 2, I can work out log of 5 in base 10 and divide it by log of 2 in base 10, and that will give me log of 5 in base 2. Okay, we will start proving these relationships now. Okay, to prove this, the first relationship, if I set log of a over b, not log of a over b, sorry, log base b of a, I'm gonna set this to be w. So by definition of the logarithms, it means I can write a is equal to b to the power w. These two statements are interchangeable. Now, I'm going to take logs from both sides of this equation, but I will choose my bases. So I will choose to take logs in base a. So I'll have log of a in base a is equal to log in base a of b to the power w. Now, log of a in base a is 1. Logarithm of any number in the same base, i.e. if the base and the value that we're trying to calculate the log are the same, this will be equal to 1. That comes straight from the definition of the logarithms. And this, the right hand side, if I use the power law that I have proven in an earlier video, this will be w times log base a of b. If I switch this over, I'll have w log base a of b is equal to 1. From here, I can write w is equal to 1 over log base b of a. But w from above here is log of base b of a. So if I substitute, I'll get log base b of a is equal to 1 over log base a of b, which is what we were trying to prove. Now to prove this next relationship, we have log base b of a. We want to prove it's log base c of a divided by log base c of b, i.e. if we divide two logarithms which are in the same bases, they will result in giving the log of 1 in the other one's base. A bit complicated in words, but mathematically it's easier to see. So to do this, I will set log base b of a to equal w again. We can call that any variable. So by the definition of logarithms, I can write a is equal to b to the power w. Now I will take logs from both sides of the equation in any base I choose. I will choose it in base c, for example. So I will get log base c of a is equal to log base c of b to the power w. And by the power law, if I rewrite this again, I can write this at w times log base c of b. From here, I can write w is equal to log base c of a divided by log base c of b. But w is log of a over b, as we defined it up here. So we get the final results that log a in base b, or log base b of a is equal to log base c of a divided by log base c of b. Now this second relationship can be quite useful because at least in the old days, I'm not sure about now, but in the old days, a lot of calculators would give you logarithm either in base 10 or what they call the natural log. And supposing you wanted to work out the logarithm base 5 of 2, you couldn't directly calculate it. But I think modern calculators can. But what we can do to use this change of basis formula, I know that log of base 10 of 2 is 0.30103, and log base 10 of 5 is 0.69897. So I can write log base 5 of 2 is equal to log base 10 of 2 divided by log base 10 of 5, which would be 0.30103 divided by 0.69897. And the answer is 0.43067. I hope you find this video useful. If you did, please give it a like and click on the subscribe button so that you get alerts when I upload new videos. Thank you for watching.